So in the last lecture, we looked at the distributive property, right? And we saw that it was kind of a tool that let us simplify an expression by eliminating the parentheses. We took the A that's on the outside and we distributed a copy of it to everything on the inside. Well, the way this is usually written, like I've got it here, there's just that one thing, that A on the outside. But really, it can be anything on the outside, including something that's bigger than just a monomial. For example, if I have this expression here, where instead of an A, there's that A plus D on the outside, I can do the same thing here. I can take that A plus D, distribute it to both of the things on the inside, and eliminate. Well, I know it doesn't look like I eliminated any. Right, I started off with 2 and I ended with 2. But now if I apply the distributive property again with those 2 individual parts, I can get rid of the parentheses altogether. And that's the method that we're going to use for multiplying out larger polynomial products. Right, so that was all very abstract. Let's take a look at an example. Right, I've got this situation here, and I want to multiply these things out. Right, well, what I'm going to do, just applying that distributive property, I'm going to take this 5x plus 4, it's on the outside, and I'm going to distribute a copy of it to both of the things that are on the inside. So this is going to become 2x times 5x plus 4 plus 3 times 5x plus 4. And I'm going to do it again. And I'm going to apply the distributive property 2 more times. First on this expression. 2x times 5x is 10x squared. 2x times 4 is 8x. Plus, and now I'll do it again. 3 times 5x is 15x. And 3 times 4 is 12. And now that's almost it. We're not quite done. Anytime you do one of these multiplications, your last step needs to be to take a close look and say, are there any like terms that I can combine together? In this case, there are. Right? We have the 8x and the 15x. If we combine them together, they become 23x. Nothing I can combine with the 12. Nothing I can combine with the 10x squared. And that's it. There's our result. That's what the product of those 2 original binomials is equal to. Okay, so we've got another example here for us to look at. This one is, I mean, it's a little bigger. There's a little more going on. We've got a binomial times a trinomial. But the process is the same. I'm going to take this big expression here, and I'm going to distribute it to the 2 things inside the second parentheses. So I'll get 4x squared times x squared minus 3x plus 4 plus 3 times x squared minus 3x plus 4. And now, just like on the last example, I have to do this 2 more times. I'll distribute the 4x squared into here. 4x squared times x squared, that's 4x to the 4th, minus 12x cubed, plus 16x squared, plus, now we'll do it once again with this second part, 3x squared minus 9x plus 12. And again, we have to look for like terms. I see what I can combine together. So I can put the 4x to the 4th and nothing. That's the only x to the 4th term. So we'll leave that 4x to the 4th. And I believe there's also only one x cubed term. So this will be minus 12x cubed. Now with the x squared, we do have more than one. I've got 16 plus 3, so that'll be plus 19x squared, minus 9x plus 12. There aren't any like terms to combine with those 2. And there's our answer. And that's what that product simplifies to. Now, some of you may have heard about this thing. It's called the FOIL method. Now, I'll be honest with you, I am not a huge fan of the FOIL method. It's a method that you can use to multiply 2 binomials together. And it only works for binomials, which is why I'm not a fan of it. The distributive method that we used here really works for any 2 polynomials. Doesn't matter what their sizes are. However, a lot of people like the FOIL method. It gets taught a lot in algebra classes. So in the next lecture, that's what we're going to stop and take a look at.